Hey guys, so here is 1.9 day 2 notes. So last time we basically graphed quadratic inequalities. Now we're going to solve quadratic inequalities. There are going to be two methods. We're going to do the graphing and algebraic method. So let's start with the graphing first. So here it says solve, so notice it doesn't say graph, but solve x squared minus 6x plus 5, which is less than 0, and we're doing this graphically. Now what does it mean to solve? So basically you have to look at what the inequality is saying. Here the inequality is saying that we want to figure out where on our graph is the y values less than 0. Okay, so that's what we're determining. Actually we're figuring out, okay, is it between maybe x-intercepts or away from the x-intercepts in which the y value is less than 0. Basically where the graph is below the x-axis. So we have negative y values. Now, in order to do this, what we have to do is first graph this function, okay? Now notice it is the standard form, so the very first thing is we got to figure out the vertex. Okay? So we do, of course, our x equals opposite of b over 2a. So we have 6 over 2 times 1, which gives us 3. And then to do our y value, do 3 squared minus 6 times 3 plus 5. Plug that into your calculator, and I think we should get 5 there. Okay? Let's see. We get 9. Sorry, we should get negative 4. I was calculating that incorrectly in my head. So we should get negative 4. So our vertex is going to be 3, negative 4. Now we're going to do our xy table to do this. So we have 3, negative 4. Okay? So make sure you pick two x values that are smaller, two x values that are bigger. So smaller we have 2 and 1, and then we have 4 and 5. Once again, just plug this into your function. So like if we plug 2, we would have 2 squared minus 6 times 2 plus 5. And we get negative 3, so that means 4 will be the same thing. And you do the same thing with 1, we get 0 and 0. Now we're going to plot these points. Okay. So we have 3, 1, 2, 3, down 1, 2, 3, 4. And then negative 3s, and here. Okay, now before we do our parabola, this is actually what we did when we graphed quadratic inequalities. We need to figure out if we have a dashed or a solid parabola. Notice here that we do not have an equal bar, so therefore we have a dashed parabola. And that is going to be very important when we have to figure out our answer when we are solving here. Okay, so we do the dash. Now this, because we are not doing any shading, so last time we did shading, here we're not. Okay, we are going to do some shading, but not like inside or outside the parabola. So your arrows don't have to necessarily go off the graph. Okay. Now solving, the step 1 was to graph the related equation. We did that. And of course, when it says you can use your graphing calculator, it means to like plug in your x values into the function to get the y values. Now we need to do step 2, which is determine the interval solution based on the inequality. So our final answer is going to have some shading, but it's also going to be an interval notation, okay? So as I said, we are trying to determine where on our graph is the y values less than 0, because that's our inequality here, less than. So that means when it's less than 0, we want negative y values. So on this graph, we're going to first just shade where is the y values negative or less than 0. Well, of course, it's going to be down here. So notice which parts of the graph here is below the x-axis, meaning the y values are negative, meaning they are less than 0. So I'm going to shade this part here. Okay. Now notice that basically our solution is between two x values. Okay, basically between two x-intercepts. So we're going to use that information to write our final answer in interval notation. I'm going to put it right here. So our interval. So let's look at the first x value. So this looks like it's at 1. So we go from 1 all the way to our x value of 5. Everything there is basically less than 0. All the y values are smaller than 0 because they're negative. Now notice we are dashed, okay? So remember anytime we wrote anything in interval notation, if we did not have the equal bar on the inequality, did we use parentheses or brackets? Oh, hopefully you said parentheses, okay? So when we do our interval, we're going to do parentheses. We start at 1, and our shading goes all the way to 5. And we end the parentheses, okay? So basically our interval is saying all these solutions, or everything that works, is between the x values of 1 and 5. Okay, now in the next video we're going to do basically the same inequality, but we're going to show you how could you do this actually algebraically. So make sure you watch the next video.